Hi, welcome to the pre-calculus lecture series. And this video, we're going to continue working on the chapter 1 practice test. This is the video number 3 for the chapter 1 practice test. We have been working the previous 2 videos. We covered the first 4 problems in the chapter 1 practice test. So we're going to start the problem number 5 here. All right, so let me go to the our practice test here. Okay, so the problem number 5 is here. So let me try to get some more, excuse me, more space here. Okay, so we want to solve the each inequalities and so for the intervals, so we want to write the intervals on the solution on the interval lines, on the real number lines here. All right, then we have problem 5, 6, and 7. Okay, so let's go to our whiteboard and let's start to solve it. Okay. All right, so here, let's see here. So the problem number 5, they want to find the inequalities here. So this is the part A. The part A, they tell you this is -4 and from 5 minus 3x and less than equal to 17. So the inequality, when we try to solve it, is just like we solve the equations. You know, you move the numbers to the side. So these ones here, we can say we -5 because this has both sides here, right? So we're -5 here. Okay, so now what is happening here? So this one will give you -9, correct? Okay. Okay, so this will give you -9, and then here this is -3x, and what happens here? This one will give you 12, and then in order to solve for x, right? So what I need to do, I need to divide by -3, divided by -3, divided by -3. So here, when they divide by -3, so what you have here is 3. So what happened here, when you divide by -3, you have -4, right? And here is the x. So the main things here is try to refresh your memory is, you know, when you divide or multiply a negative number, what happened to your inequality sign? The inequality sign, you switch here, right? So here it used to be less than, then here going to be x is 3 is greater than x. So the same for these ones here, you need to switch the directions here. So this is the most important things, and they try to review is, you know, when you divide or multiply a negative number, then your inequality sign should switch. So in here, we can rewrite these ones here because we typically write the positive number here, right? So this is -4. So that means x is less than 3. So still, they open the same place, right? So in the greater than equal to -4. So if you want to find in the interval notation, so the solution will be what? Will be between the -4 and the 3, right? Be careful here. You know, I use the bracket because of what? Because of equal signs, right? Then you use the parenthesis because they don't have an equal sign. So this is the interval notation, or you can draw, you can draw on the real number lines here. So this is 0, this is 1, 2, 3, and there's 1, 2, 3, 4. So it's -4. So how do you draw in the real number line? You guys still remember? So if it's the equal sign, you have what? You have a solid dot, right? So x is between -4 and the 3. So then the 3 is a circle because the 3 does not have the equal signs here. Okay, so this is the part A. Try to test you. What is here? You remember, right? This is the important when you times or multiply negative, you switch the inequality. You might want to write yourself a note for that so you won't forget. Okay, the second one, they also want to test another way, how do you find the inequality? So this is a typical, when we try to solve the polynomials. So what do? We kind of factor it, right? So here is, if your polynomial, you can factor like these terms here. Now, how do you solve the inequalities here? So the way you solve the inequality, so the first thing here is you set each item equal to 0 to see what is your x value. So what is this x value? So your x equal to 0. This one is x equal to 1. And what is here? X equal to -2, right? Okay, so after that, the way to solve it, okay, so in here, what you do see here, you draw that in the real number lines here. So this is 0, this is 1, 2, 3, and this is -1, -2, -3. Okay, so you kind of, put it, okay, so 0 is one of the solution, 1 is one of the solution, and -2 is one of the solution, right? So it's kind of like you divide the whole real number line into 3, right? So into 3 zones here. So the way I typically like to solve ways like this. Okay, so like for the first zones here, right? So you choose any number in these intervals here. So I would say I would choose -3. So the -3, the x is negative. -3 minus 1 is negative. -3 plus 2 is negative, right? So in here, you will get a negative, negative, negative. So when you multiply, what do you have here? You have negatives, right? Okay, now let's take a look at another one here. Okay, so these intervals here, let's take a look here. This interval is -2, so you choose any number. I say let's choose -1 here, right? If I choose -1, so what is x is negative? -1 minus 1 is negative. -1 plus 2 is what? It's a positive. So negative, negative, positive. What do you have here? You have a positive. Okay, now let's choose this, now let's take a look at this intervals here. This interval, choose anything between 0 and 1. Okay, I say 0.5. So if I choose 0.5, this one is positive. So 0.5 minus 1, so this one is negative. 0.5 plus this is positive. So what do you have here? Negative, positive, negative, positive. So you got a negative, right? Okay, so now, same color. Okay, now the last interval, well, choose any number, I choose 2. So first one is x equal to 2 is a positive. 2 minus 1 is a positive. 3 plus 2 is a positive. So the last interval is positive, positive, positive is a positive, right? Okay, so now you take a look, you say, hey, what is my inequality sign? My inequality sign is greater than 0. That means the positive. So my solution will be the one I have a positives here. Right? So these two intervals will have a positive. So what is our solution? Because it does not have equal sign. So this will be the -2, 0, and the union. This is a continuous goal, right? Okay, so it's not a stop, it's a real number line. So from 1 to where? 1 to infinities here, right? So if you want to write it, in the notations here, so this is 0, -2, and 1, and right, so what you can do here, so your solutions will be from the -2 to 0, so you draw like this, then 1 to infinity, so you draw like this, right? So this is another way to show you how to do. All right, so how to do the polynomial type, you factor, right? You factor, then you find the interval. Okay, so the part C here is going to show you another one. Here is absolute value. Okay, is less than 3. So in order to do this one, we need to review some absolute value properties here. And you might, I don't know you remember or not, when we break the absolute values, right? So if I break, so if I know that if I set x here, it will be equal to x just by itself, or equal to negative x, right? So this is the situation when x is what, greater than equal to 0, and this is the situation when the x is less than 0, right? So this is the first thing. So every time when we deal with the absolute value, then we have to, we need to always have 2 branches here, right? So like the problem number 4, part G, that's how we break the absolute value. Okay, now for the absolute inequalities here. So the way we break this, right? So whatever is inside here, if this is less than or equal to some value, okay? So this is we call is the end condition. So what I mean the end condition. So the way you break it, this is x is less than a and greater than negative a. See here. All right, so right, because every time you break the absolute value, you always need to have the positive and the negative. So this is end condition. It's very important, right? So remember here, this is less than, so it's end condition. Okay, so the same way, if you say x is greater than equal to a, and this one, we are called, this one is or conditions here. So what is or means here? That means that you break like this one. So you still break the positive and negative. So it's x greater than a, or x is less than equal to negative a here. All right. So you will have the 2 branches every time when you're dealing with absolute value. Okay, so now let's take a look at the part C here, right? So the part C, I have x minus 4 less than 3. So because this is less than, so what condition we said? This is end. All right. So how do we break it? So just like we say, so you need to do x minus 4 less than 3 and greater than negative 3. That's right. So you put an end, it's in between these 2, right? So you put an end. Now we can solve it. You just plus 4, plus 4, plus 4. So what is here? This is 1. X is what? 7, right? So you can write the solution is 1 to 7 in the interval solution, or you can just plot it in the real number lines. So here, this is from here to here, right? Okay, so this is how do we do the absolute value. So I can switch this like to be greater than, right? And then you need to break it into 2 branches here, all right? Okay, so now let's take a look at part D here. Part D, the 2x minus 3 and x plus 1 and less than equal to 1. Okay, so when we do the fraction inequality, we have to move everything, over and combine into 1 fraction. What that means here, so this is 2x minus 3, x plus 1, and minus 1 is less than equal to 0. Okay, some people they want to use the cross product, and you're going to miss some important information when you use the cross product here. So you move everything over. Now, what you do, you find a common denominator, right? So this is a common denominator. Okay, so the common denominator is x plus 1, x plus 1. Okay, then here you combine it. So this is x plus 1. So this is 2x minus 3 minus x plus 1. Okay, so here, this is x plus 1. Then this is 2x minus 3 minus x minus 1. Okay, so this is x plus 1. So this is x minus 4. Okay, and now after that, just like you did for the polynomial factoring, you need to set the top one equal to 0 and the bottom one equal to 0, and to see what is the value of x. So the top one equal to 0, you can get x equal to 4. And what is this one? X equal to -1, right? Okay, so now we will do the same things here, right? So in here, so this is like 0. So this is 1, 2, 3, 4. So 1, 2, 3, 4. This is -1, -2, -3, -4, and -5. Right now, you kind of define the x equal to 4. So it's here. X equal to -1 is here, right? So you kind of break this line into what? Into like the 3 zones here, right? Okay, now we will do the same thing, like checking, right? Okay, so now choose anything on the first one. So I say, hey, I choose -3. So if you choose -3, so -3 minus 4 is negative. -3 plus 1 is negative. So this is negative over negative. So what do we have here? We have a positive, right? Okay, now you choose anything here. Okay, so you choose anything here. So I will say, okay, this is a fraction. I choose 1. So 1 minus 4 is what? It's negative. 1 plus 1 is what? It's positive. So minus positive, what do you have here? You got negatives, right? Okay, so now let's take a look. The last intervals here. Well, let's choose 5. 5 minus 4 is a positive. 5 plus 1, 6 is positive. So what do you have here? Positives, right? Okay, so here is a positive. And then what is your original one? Is your original one is less than 0. This is the reason why we want to move everything to one side, because we want to use less than 0, greater than 0 properties, right? So the less than 0, so where is the solution? Boom, 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 it's here, right? Here is the solution, it's less than 0. So now let's take a look here. So how do I write it? So the less than 0, so that means it's from -1, okay? Okay, so it's from -1 to 4, okay? So now let's take a look. I'm using the bracket or parenthesis. Okay, because this is equal, so I will use a bracket here. And for this side, and if I use a bracket, that means x will be equal to -1. But I know that x what? X cannot be the -1. Why? Because the -1 is not in the domains, right? So x cannot be the -1. So that is why in here, what you need to do here, so you need to use what? You need to use a parenthesis here, because you need to be careful, right? Because -1 is not in the domain of these functions, right? So this is the key part, yeah? So for these problems here, I think you need to pay close attention to the part C and the part D. How do you do that, right? So be careful about how to break the absolute value, and be careful how do you do the fractions here, okay? So you might want to find some problems in the book with absolute value greater than some number, and see what is your inequality looks like. Okay, so now let's go to the problem number 6. Problem number 6 is pretty straightforward. Basically, it's the linear functions here. Okay, so this is number 6 here. Okay, so we have 2 points. P is -3 and 1, and the Q is 5 and 6. All right. Okay, so the first thing is it tell us is here, put in the coordinates plans here, right? Okay, so put on the coordinates plan. Okay, so that's So this is the coordinates plane. So it's 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Okay, so the first things here, let's say, okay, put this into the, so into the coordinate plane. So -3, 1. So it's 1, 2, 3, 1. So it's this point, right? So this is -3, 1. So this is my P. Then my Q is 5. So it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 5, 6. Right? So this is my Q. It's 5, 6. I think everybody should know how to find it, right? Okay, so this is the part A. All right, so this is the part A. Then the part B, let's say find the distance. So basically the part B wants you to review the formula for the distance. So let me write the distance formula. So you might want to write this one into a separate piece of the paper. And so you will remember the distance formula. So the distance formula will just be x1 minus x2 square plus y1 minus y2 squares, right? Okay, so for this, for these 2 points here, right? So let's see the distance formula. Just be very careful about the negative positive. So 5 minus -3 and the whole thing square plus 6 minus 1 to the square. So what is in here? So 5 minus 3 is 8. So it's 64 plus 25. So what is the distance here? Is the square root of the 89 here, right? So the part B basically is trying to test you. Do you remember the distance formula from the algebra 1? Okay, the part C is here. They say to find the midpoint, all right? So now I need to write the midpoint for you. So what is the midpoint mean? That means if you connect these two, you got segments, right? So where is the middle of this segment? So the midpoint formula, you might want to write it into a separate piece of the paper also, so you might need to use it. So you will remember, right? So the midpoint formulas will just be, it's a point, right? So it will just be x1 plus x2 divided by 2, right? And y1 plus y2 divided by 2 is just the middle point. Okay, so what is the middle points here? Will just be, so that this is the middle point. Okay, so will just be 2. So the midpoint here will just be 2, x1 plus, right, 5 plus, and 6 plus 1, 2. So the midpoints here, it will be 1 and 7 over 2. So it's a kind of a, because, plus is 1 and 7.2. So yeah, so it's right here, right? So that's what is the midpoints here. Okay, so now the C's here. Oh, these ones here, this also is very easy. So this part C's here, they say is find the slope. Okay, let me write down the slope formula just in case if you don't remember, right? So I think everybody should remember. So the slope formula, your school teacher will say is rise over runs, right? So it's y2 minus y1, x2 minus x1. Okay, so all this is a good review, right? So the slope here, so what is the answers here? So the slope will be, the y2 minus y1, so 6 minus 1, right? Then x2 minus x1, so 5 minus -3. So what is my slope here? 5 over 8, all right? 5 over 8. Okay. So now let's take a look at part E here. So part E, they talk about find a perpendicular line bisector of the line that contain the PQ, P and the Q's, right? So the ones here, right? So one thing here, we need to know the word, what is the bisector mean? Okay, bisector, that means equally. Okay, so the bisect, that means the equally divide. Equally divide. So that means I'm going to find a line is perpendicular to PQ. But where is this line go through? Let's say this line is going to bisect. That means this line going to cut the PQ into a half, right? So that means how I'm going to do that? So that means it has to be perpendicular. And then what? And go through what the points here? Go through the middle point, right? Because that's what is a bisector means, right? Okay, so we know the slope, what is the slope for the perpendicular lines, right? So what is the slope for the perpendicular? You should know that, we learned this a lot. So the slope, I know the PQs, right? So for this line, so PQ, the slope here, slope of this line is equal to the 5/8. So what is the slope for the perpendicular? We talked about it before, we learned that it will be the reciprocal of the slope and then add a negative sign. So 5/8, that means you flip reciprocal, so it's A/5. Then you add a negative sign. That's right. So now, also, this is a slope and one point. What is one point? Like we discussed before, this point is goes through the middle point, right? So the middle point is 127. So then I use I'm going to use write down another formula for you. It's the slope and 1 point formula. Don't know you guys remember or not, the slope and the 1 point formula, the way we do it is y minus y1 is equal to the mx minus x1 here. Okay, so now let's try to substitute here. So y minus y1 is goes to the middle point, so it's a minus 7/2 is equal to negative A/5 x minus x1, so it's x minus 1 here. All right. Okay, so now in here you can simplify. This is negative A/5, and this is negative is a plus A/5. Okay, so you can move that over 7/2 plus 7/2. So this is y equal to the negative A/5x. Okay, so 7/2 plus the A/2. So it will be, it will be 5.1 here, right? So this is my linear equations here. Okay, now the part F here. Okay, part F here is like it's kind of like the bridge through the next question, number 7. They said find the equation of the circle, and for which the PQ is the diameter, right? So now we need to review the circle formula, right? The circle. So what is the circle formulas? Here we say is x minus h to the square plus y minus k to the square is equal to r squared, right? So then the h and k is the what? Is the center, right, of the circles here. Then the r is the radius. Okay, so let's say the PQ is the diameters, right? So the diameter, we already calculated square roots of the 89, right? So what is the r? The radius will be half of the diameter. So it's the square roots of the 89 divided by 2, correct? So where is the center? Center is the middle point, right? So center is 1 and 7/2. Okay, so what is our formulas here? Right now, it will be x minus 1 square plus y minus 7/2 square equal to r square is 89/2, the whole thing square. All right, so now here we have x minus 1 square plus y minus 7/2 square. What is the answer? 89/4. So this will be my circle formula. Right, so this problem, the problem number 6 is very good problems, right? We talk about so many formula, right? So the distance, the midpoint, slope, what is bisector, what find the perpendicular, slope, and the 1-point formula, and the circle formula. All right, so that's it, all right? Okay, so now let's go to the, so because we already talked about the circle, so let's continue to the number 7 here. So the number 7 is talk about find the center, the radius for each circle. Okay, so the A is here is x squared plus y squared is equal to 25. So I know, so this you can write as x minus 0 square minus y minus 0 square equal to 5 to the square. So where is the center? So center is at 0, 0, and the radius is what? Is a 5, right? So for these ones here, it's easy to graph here. So this is a 5, negative 5, 5, negative 5, right? And here is your center. So your circle go like this. Of course, I cannot do, not too bad. Not too bad. Of course, this is a solid line here. Not too bad. Okay. Okay, now let's take a look at the next ones here. So the next one is also pretty straightforward, and is they give you this ones here. So this is x minus 2 square plus y minus 1 plus 1 square equal to 9. So this will be x minus 2 square plus y plus 1 square equal to 3 to the square. So where is the center? The center will be 2 and the negative 1s, right? Because we talked about the previous one, we have the general formula. So if here, maybe you can rewrite this one, may help you. So it's y minus negative 1 square equal to 3 to the square. So that's why your center is at negative 1s, right? And what is your radius? Radius is 3, okay? So now let's take a look at how do I graph it. Okay? All right, so how do you graph it? So this is how do you graph it. Okay, so now here, okay, so let's see here. This is 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Okay, and this is 1, 2. Okay, okay. So now let's do the center. It's 2 and the negative 1, 2 and the negative 1, 1, 2 and the negative 1 is here. The radius is 3, right? Okay, so now 3 is 1, 2, 3. So this is the top 1, 1, 2, 3. This is bottom 1, 1, 2, 3, and the 1, 2, 3 here, right? So you kind of got it, right? So now this is your circle. Hopefully I can do a good job. This one also, not bad, not bad. Okay, so here. Okay, so this is my circle. Okay, so the part C is here. So those two are pretty easy. The part C is the key things here. So basically you have this is x squared plus 6x plus y squared and minus 2y plus 6 equal to 0. So the purpose for the part C is they want to review the completed square methods here. All right. The reason why I completed the squares, right? Because we want to use this formula, right? So I know the a plus b squared, right? So a plus b squared is equal to the a squared plus 2ab plus b squared, or you have a minus b squared is equal to the a squared minus 2ab plus b squared. So I hope that I can change that to like the standard form, like something like that, right? Okay, so now let's take a look. So for the x, let's focus on the x here. So this is x squared plus 6x. So in order to have 2ab's here, right? So it's 2ab's, right? So now I need to what? So here I will say x squared plus 6. I can change it to a 2 times 3 times x. Correct? So it's a 2ab. So now you can, so this is 3, right? So now you will say, hey, this is plus b squared. So it's 3 to the square. Correct? Okay, this is b to the square. Okay, now I'm also going to look for the y's here, right? So let's get a different color. So this is y. So then this is plus y squared minus 2y. So it's minus 2 times 1 times y, right? In order to apply the formula, so what is here? So this is 1. So I need to plus what? So I need to plus 1 to the square. Okay, so now for this one, the negative 6, I can move over to here, right? Okay, so one thing here, you said here, you say, okay, now I completed the squares, right? But I add something extra. I add something extra, right? I cannot just randomly add something extra. So what I need to do here, I need to add back here. So it's a 3. So what I have here is 10, right? 3 to the square is 9. So you cannot just add anything. You need to kind of balance it back. So now if you take a look here, let me see here. If you take a look at all these terms here, right? So this is a complete square. So this is x plus what? This is x plus 3 to the square. So the same thing here. What is here? This is minus, so I need to here. So this is plus y minus 1 to the square. What is here? 4, right? Okay, so this is x plus 3 to the square plus y minus 1 to the square is 2 to the square. Okay, so where is the center? So center will be negative 3 and 1. And the radius here, radius is 2. All right, so that's it. And now the plotting will just be pretty easy, right? Okay, so let's do here. All right, so here we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right, and then negative 3 and 1. So this is my centers, right? And then radius is 2, so I go 2 units. 1, 2. So 1, 2. Go up to 1, 2. Go up, go down 2. So this will be my circle. All right, so let's see. I can put a nice circle here. All right, not bad. Okay, so that's my circles here. Okay, so that's it, right? So for the problem number 7, so basically they want to review the formula for the circle, and also this is important, right? So they want to review the completed squares here. Okay, so that's it for the practice test for chapter 1. It's a good review test for what all you learned in the algebras here, and those skills we will need in the pre-calcs here. Okay, so now you have all the solution for the practice test number 1. So make sure you review them and practice them, and good luck when you come to take, when you have the exam on that. All right. That's it. And it's a nice talk to you, and you have a good day. Make sure you always practice, right? So you need to practice the practice test problems and to be good at it. All right, that's it. Have a good day, and talk to you later for our next units here. All right, bye.